Number 52, are the following functions inverses? If not, rewrite the second function so that it is an inverse of the first. How can we find the inverse of this function? That's what we're trying to find. The way we do that is we're going to do a few steps here. First, we're going to set f of x equal to y. So let's change it back to y. So y equals 3x plus 1. Okay, this is the key part to the inverse. You're going to, everywhere you see a y, you're going to change it to an x. Everywhere you see an x, let's change it to a y. So now this is a y. Let's go ahead and change it to an x. Okay, everywhere we see an x, we're going to change that to a y. Okay, now what we're going to do is we're going to solve for y. So you got to be able to manipulate the formula here a little bit and solve for y. So the first thing we're going to do is we're going to subtract 1 from both sides. Okay, and I'm going to rewrite it up here. We're going to have x minus 1 equals 3y. And then we're going to divide by 3. So let's divide each term by 3. And we're going to have 1/3 x minus 1/3 equals y. So you can see here, the final answer also will change this back to g of x. I guess that's what they're calling the inverse here. So let's call that g of x. So g of x equals 1/3 x minus 1/3. So again, to find the inverse, what we're going to do is set this to equal to y, f of x equal to y, switch them, solve for y like what we did here, the 2 steps, and then your inverse will be g of x, or sometimes it's called f of negative 1x, with that little negative 1 up there. So that's the answer. So is this the same as this? Obviously not, and the answer in this problem would be D.